Good day, class. In this lesson, we will learn to write equations of circles. We'll begin by discussing the required items that are needed to generate a circle. So here we have a circle plotted on the coordinate grid. Note that we have to have a center in order to draw this circle. We also have to have the radius in order to draw the circle. And then you might note that the radius goes around the circle the same length in every position. There are just infinite radii, if you will, inside of this circle. And we just have one of those sketched here. So note, if you have the center and if you have a radius, you can always generate the equation of a circle, and also you can sketch the graph of a circle. So that will be the theme throughout this lesson today. Also note that a radius is derived from a diameter because a radius travels from the center to one end of the circle, but a diameter travels from end to end going through the center. So we want to be thinking about the diameter and the midpoint whenever they are relevant based on the information that we're with which we might be dealing. Moving right along, I want to remind you about the standard form of equations, one of which you might be familiar, which is the equation of a straight line. Y is equal to mx plus b. So we recall this one vividly because we've been dealing with it for quite some time at this stage. So remember, there are certain elements of the standard form of an equation, such as the equation of a straight line, where we can recognize where the slope lies. The m, or whatever value is sitting in that place, represents the slope of a straight line. And also the b, or whatever value is sitting in that place when the equation is written in this form, represents the y-intercept, or where the line crosses the y-axis. So if we know information like that about a straight line, you should also assume that we have general information about all equations, or information that can be generalized about all equations of a circle. So here we have the standard form of an equation of a circle. And there are a few things here I want to highlight. Recognize where the signs are, those negatives inside of, or those minus signs, if you will, inside of the sets of parentheses. The variables h and k that are somewhat new to us at this stage that we'll talk about a great deal as we study equations. And also the squared values. Also note the r on the right hand side of the equation, which will represent, you'll learn in just a moment, is the radius of the equation of our circle. So, or the radius of the graph of our circle. So let's talk about those items in depth. Remember, you probably want to write down this equation because you'll refer to it quite a bit and you'll use it quite a bit in order to generate the equation of a circle, and sometimes in order to graph the equation of the equation of a circle, pardon me. Remember, the center is found at HK, and we'll dive into that a bit more in just a moment. And also the radius is the variable r that you note here on the right hand side of this standard form of an equation of a circle. Moving right along, here's an example. You're asked to find the equation given some general information. In this example, you're given the center. It's located at -5, 2. That is a point on a graph. And also the radius. It is a length of measure. It could be in inches, it could be in feet, it could be in miles. We don't know, but it has a length of measure. The radius has a measure of length 3 units, whatever units those might be. So then we can apply that to the standard form of the equation of a circle to write the equation of a circle. Keep in mind, as long as you have the center and as long as you have the radius, you can write the equation of a circle. So always keep in mind, as we're dealing with the equations of a circle, there's barely anything that we can do with that involves a circle where you don't know the center and you don't know the radius. So let's always highlight those two items. So then I'm going to delete, if you will, the standard form unknowns here. My H, if you notice, is deleted. My K is deleted, and my R. And those are deleted because I'm going to replace them with the values that I know. As I said a moment ago, the center is identified by the HK. So whatever value is sitting in the point, the center point, we have our center point of -5, 2. Note that those are coordinate points on a graph. -5 steps on the x-axis, 2 steps on the y-axis. So then I can substitute those values in for H and K being respective of my signs, and it should look like this. So notice how I've substituted -5 in for H. So I've removed the H, just the H, and I've replaced it with -5. I've removed the K, just the K, and I've replaced it with +2. And I've done the same thing with the radius. I've removed the R and I've replaced it with length measure of 3. And so now all that remains is to simplify what I have here based on the rules of algebra, based on what I already know. And now we see the equation of this particular circle that has a center at -5 and at -5, 2, and a radius length measure 3. And I can actually go so far as to plot this. Now remember, these are sketches, so we're in the ballpark here, but I'm going to place that center at -5, 2, as you note here, -5 steps in the x direction, +2 steps in the y direction. Place that center point there. And then I'm also going to recognize that my radius has 3 units in length measure. So 3 steps, if you will, in any direction, really, because we're talking about the radius of a circle, which there are infinite number of radii inside of a circle. So once I have that measure of 3, and remember, this is a sketch here, so the bigger this graph gets, the more you might note that I'm a bit off. But then I can sketch that circle, and then fortunately, if you're using the MyMathLab program, then or an automatic program that will automatically connect to where it is you're trying to visit on your coordinate plane, then your circle will be exact. So note, what are the key elements here? The center, it's plotted. The radius is sketched at 3 units, and then the circle is based upon that. Moving right along, in a second example, we're asked to find the equation given, in this case, a center at -2, 2, and this equation is passing through to a point, another point on the graph, to -1. So we don't have all the information. We do have the equation of a line, the standard form of the equation of a circle, pardon me, not a line, the standard form of the equation of a circle. So we'll receive that, and we have the center. So that's a start, but we need the radius. So we can derive the radius from the information that we're given. Notice how a circle such as this might look. Here's the center at -2 on the x-axis, +2 on the y-axis, and it's passing through this point, +2 on the x-axis, -1 on the y-axis, and notice that is a length of measure there between the two. So if the center is at one end of this line and the radius and it passes through this second point, then clearly we can measure the length of that line, and that will tell us the measure of the radius. So we'll have that second element that's so crucial. We have the center. We're going to use the distance formula to measure the length of that line so that we'll have the radius. And the distance formula is pretty easy. If you recall it from a different lesson, we substitute those values into a distance formula. I'm going to kind of just roll through this because we actually learned this in a separate lesson. And then you simplify and you discover that the length or the distance from one of those points to the other point in this example is 5 units. So if the length of that line is 5, if the distance from one point to the next is 5 units, then the length of that line is 5 units. Therefore, the radius of this circle is 5 units. And so we now have both the center and the radius. We can substitute those values into our equation, the standard form of our equation, much like we did in the previous example. Simplify. Be careful, pause it if you need to. Be careful with your signs. Very easy to get disoriented with our signs here. And then we can actually sketch the circle based on the information that we have. Moving right along to the last example, we here have been given the diameter and we've been given endpoints. Remember, if you can derive the center and the radius, then you can substitute and write the equation of your circle based on this standard form equation. So here are the endpoints sort of sketched. You see, the bigger your screen is, the more you might see them a bit off, but One endpoint is at -3 on the x-axis, +4 on the y-axis. Another endpoint is at +3 on the x-axis, +4 on the y-axis. So with that information, I can actually use the midpoint formula to determine what is the center, because two endpoints of any circle have a midpoint, and those midpoint right in the middle between two endpoints on any circle are going to be the center. And so the midpoint formula will give me, it's simply an average of my 2-point values, my x's and my y's. And so based on the previous lesson, recalling the midpoint formula, I can simplify and determine that 0, 4 is actually the center of this circle. And I can plot that. I have my center. Now I'm halfway there. I need to determine my radius. Think carefully. What will you do? Pause this if you want an opportunity to think about it on your own. Otherwise, I'll go ahead and say the length from the center to an endpoint will give you actually the radius, the length of the radius, because that is a distance, a measure of length, distance, radius. All of those go hand in hand. So based on a previous lesson or even the previous example, using the distance formula, you can determine that the length of that measure is actually 3 units. And so now we have both our center, we have our radius, and we can substitute that information into the standard form of the equation of a circle and simplify. Remember, be very careful because it's very easy to misplace your signs. So pause this video, carefully walk through those signs, make